let's get into one that's a little bit more complicated though, so you can see how this process works. Okay, so first I check to make sure it's in standard form. It is. I've got my a x squared plus bx plus c. My a value this time is -2. My b value is 4. And my c value is 1. I can go ahead and say that this is going to open down because that a value is negative. So we expect to see something that's curved this way this time. Let's go ahead and find the axis of symmetry. So remember the formula for that is x is -b over 2a. We know that b is 4, so b is going to be -4 over 2 times -2. Okay, 2 times -2 is -4, so I have -4 over -4, and -4 divided by -4 is 1. So my axis of symmetry is x equals 1. So let's go ahead and go to where x is 1 and draw ourselves a vertical line there. So let's see if I can do this. Okay. All right. There's our axis of symmetry. So that's going to be basically the line that cuts this parabola in half. Okay. Now we are ready to start constructing our table. I'm going to put this x value of 1 in the middle of my table, and I'm going to go ahead and plug in -1 here. And I'm going to, it says y, but remember you can always replace that with f of x. So I'm going to write that as f of x just so we can keep track of what we're doing here. So now I want to know, what is f of 1? What is the value of this function if I plug in a 1 here? So I'm putting 1 everywhere there's an x. 1 squared is 1. -2 times 1 is -2. 4 times 1 is 4. -2 plus 4 is 2, plus 1 is 3. Okay? So that means that my vertex then is 1, 3. So we're going to go over 1 and up 1, 2. I'm going to pick a different color. Over 1 and up 1, 2, 3. And that's going to be my vertex. Okay? Next, we're going to start constructing our table. I always like to choose 0 as one of my values. 0 is less than 1, so I'm going to put it right there. That's because this is choosing 0 for your x is going to give you your y-intercept, which is good to have. So let's do f of 0 then. That's going to be -2 times 0 squared plus 4 times 0 plus 1. 0 squared is 0. -2 times 0 is 0. 4 times 0 is 0. And I'm adding 1. And 0 plus 1 is 1. So that means that the point 0, 1 is going to be my y-intercept. Okay? Now, remember I told you to keep in mind that this axis of symmetry serves as a reflection line. So if 0, 1 is a point, then 2, 1 will also be a point because that's the mirror image of this one. So 2, 1. And that saves me a little bit of work in choosing points. From here, the other 2 points can be whatever, so let's just go -1. You don't want to pick anything too large because parabolas do grow pretty quickly once you get away from that vertex. So we don't want to end up having to plot, 10, 20 or something like that. So let's just choose -1. I'm come over here. You will need lots of scratch paper for this. So f of -1. Y'all can see now why I changed it to f of x notation, because it just saves me some time and helps me keep track of my scratch work a little bit better. So this is negative 2, negative 1 squared, plus 4 times negative 1 plus 1. Okay, negative 1 squared is just 1. Negative 2 times 1 is negative 2. 4 times negative 1 is negative 4. Negative 2 plus negative 4 is negative 6 plus 1. And then negative 6 plus 1 is negative 5. Okay, so that means that when my x value is negative 1, my y value or my output is negative 5. So I'm going to plot that point starting at the origin. I go left 1 and then down 5. And then I want to get the mirror image of that, so the reflection of that point over this axis of symmetry. It is 2 points to the left of the axis, so I'm going to go 2 points to the right and put a point right there. That ordered pair to fill out my table is going to be 1, 2, 3, and then down 5. So my x value is 3, my y value is negative 5. And you can check that math to make sure it works out to negative 5. You don't have to check the reflection points every time, but you know, for the purposes of showing you guys that that really does work, I'll show you. So 3 squared is 9, so negative 2 times 9 plus 4 times 3 plus 1, and then negative 2 times 9 is negative 18, 4 times 3 is 12, and when I add this, negative 18 plus 12 is negative 6, plus 1 is negative 5, which is exactly what we got. So then the last step after we've plotted the points is connect them with our arrows. Bear with me because I'm bad at drawing this. Oh my goodness. Okay. So you get a nice pretty arrow there. There is actually a website that's really nice for graphing these, so you can check your work, and also if you're bad at drawing them like me, you can see what they're supposed to look like. That website is desmos.com, desmos.com. When you get there, you just hit start graphing, and it gives you a nice pretty coordinate plane, and you can go right here and type in the equation. So negative 2, y equals negative 2, x, and then you can just do shift and then 6, and that would put you up, or you could use this button right here and get this squared, and then plus 4x plus 1. And now you can see that nice pretty graph and how it's supposed to look. So sorry about that, guys. Let's look though at a couple more details about this example. First of all, the maximum is going to be that vertex of 1, 3. Again, remember that you're either going to have a max or a min, depending on whether it's opening up or down. In this case, we just have a max because we just have a top point. Now, the roots. In the last one, it crossed that x-axis at a really nice point. Here, let's go again back to the pretty one. You can see that this is going to be a decimal. If you hover over it, it'll tell you it's at negative 0.225 and 2.225. So when you're graphing it by hand, if you don't have the website up or you don't have a graphing calculator, you can just estimate that. When I'm looking at my estimate here, well, I did a really bad job of drawing it. It's especially hard with a computer, but we would say that that's about negative, we'll try negative 0.2 and 0. And then the other one, that's a decimal. And then the other one is, we'll say about 2.2 and then 0. Okay, so if the roots aren't perfect, you can just estimate. It's part of graphing is there's always a little bit of estimation involved. Domain, though, is not going to be an estimate. These arrows are going to go on forever. I'm going to flip back to Desmos real quick and just show you that if I zoom this out, this thing keeps on going forever and ever, and it gets wider as it goes. So these values keep going forever. Let's zoom back in, and you can see that it gets wider and wider and wider as time goes on, and it does also keep going down. So my domain is going to be all real numbers, or negative infinity to positive infinity, however you want to write that. The range, remember that to do the range, we start at the bottom. Well, you just saw there is no bottom. It goes to negative infinity. The height, though, the highest point we have here is that y value from the vertex is 3. So my range, it never gets to negative infinity. It does equal 3. So that's all my information about that.